Okay, architecture as decision framework. Like first, like why I prepared this presentation, why I wanted to talk about it. So fairly recently in Calgary, I've been in a Calgary Software Crafter event, and in after party we started discussing like architecture and how it affects engineers. And most engineers who like writing code or engaging agents like day to day are pretty pissed with architects. They were like very temperamental about like that, like architects like standing in the way of their work. They coming in say like you cannot do this and that. And I thought about like why and how I became an architect. I worked as a software engineer, and when opportunity presented itself, I like gladly switched into architecture because I was to an extent pissed with like how with my interaction with architects and how it was like imposed on me when like people coming in and said like, oh, we cannot do this and that, and like you say, okay, have a perfect solution. Why you like standing there and like from my point of view wasting company money. So after a couple of years as an architect, hoping to do like a better work, I saw like maybe it would help like more people if I presented like what architects typically do and why it's still like valuable to do it and why it's not just like impediment for an engineer and extra cost for a company. So typical engineering experience. You presented with a problem, you found a solution, you ship a solution, everyone is happy. You're happy, like you get your shot of dopamine because it's working whatever is expected from you. Business is happy, they making money of the feature you build. So like no need for anything else, like a perfectly working system. But the organization grows, and now you suddenly have like some constraints that like coming out of nowhere, red tapes that you need to cut through, some weird requirements like you have to split your data into 3 different databases. You cannot store it all together. You cannot use MySQL. You have to use PostgreSQL, like specific version, like that doesn't help from a perspective of engineer. It's not like moving organization forward. Like it feels like you're fighting with like body is fighting with itself, like engineers versus architects. So Dropbox didn't really bother it. So it's like we have a business idea. Everyone need to share files. We have Python. Let's go and build our massive systems that like everyone can share anything. Like let's use internet infrastructure to its fullest. Like send a lot of data around. And they did build a successful business. They like made quite a lot of money. I don't know like valuation of Dropbox at its peak, but they did good. Like most people here probably know Dropbox. But at some point, they said, "Oh, we need MyPy." What is MyPy? MyPy is strong typing for Python, but like why this picture is here is like you have like seen like some scientific machine and then like putting like pieces of foil everywhere because they realize that like, oh, heat insulation was not sufficient. It's some like quantum testing blah blah blah. So basically heat fluctuation like really screwed them. So they have to like strap this foil around. MyPy is a similar thing for Dropbox. It doesn't bring any value. It's like not a core business. It like made them $0, like, but they have to invest into like developing MyPy, making it consistent, like ship it, like have pay people like to work on it. To what end? So it was a recovery. So like you have this massive code base. I read statistics that like they reached 4 million lines of code in Dropbox, and say like, we cannot move forward. Like whenever we bring new feature, we break something that's already existed. So say like we need a way out. We need something that will catch problem like faster than like through the integration cycle, through the tests and end user complaining. So they introduced types. Facebook, fairly successful company, made billions. And it's mostly running PHP with a little bit of C++. At some point, they figured out, yeah, they, to an extent, stuck developing new features, like getting like too expensive. And they introduced Hack and HHEVM. So what is Hug? Hug is a type system for PHP. What is HHVM? It's a faster VM for PHP to make it more performant, because like when you have billions interactions a day, performance does matter. So like if you can shave off like 2% of your resource utilization, like if your resource utilization like cost you like billions a month, it's 20 million. It's like nothing to sniff about. So like they develop these solutions, and the Hack and NHVM is fairly serious engineering undertaking. So they cost them a lot of money. Same story as with Dropbox. They didn't make them any money, but they were big enough so they can go this way. And okay, like we develop Hack on top of PHP and at HVM to run Facebook PHP on it. Interesting way is that like how they did like approach like this. Like they didn't create a Hack on PHP, even so they like have massive experience with PHP. They didn't even use C++, even so they like had quite a few engineers in Facebook familiar with C++. And Smug Camel comes into picture. So they used a camel to develop it. And it's ironic because a camel on itself already have like a very decent type system. Like it's as sound as it can be in among programming languages. Everyone familiar with soundness and completeness? So who familiar with soundness and completeness? Okay. So soundness of program means it cannot be an invalid state. So if your program like 100% sound, it's like never get into a state it's not supposed to be. So this can be applied to type systems that like properly design the program, properly designed types in a sound type system cannot represent invalid state. So basically, if it's well designed, when you write code, you won't be able to write something that doesn't make sense. Simple example is like you can use integers or strings for your identities. You have a product ID, you have user ID. If your example of non-sound type system is like it's an integer or a string or a GUID, and you can take user ID and try to query for a product with such an ID, and it will try to execute to the best of its ability. It doesn't make any sense, but your type system allows it. Sound type system example is like your user ID of a type of user ID. And therefore, when you're calling a function with like 2 parameters, if it's a user ID and a product ID, you cannot swap them around. Like at the time of like a compilation, usually in IDE, it tell you, okay, does make sense. So that's a soundness. Completeness, on the other hand, is like it allows you to represent all valid state. You can model whatever your business is desire. So if you cannot model it, you cannot make money, your program is incomplete. So slight deviation. So basically, a camel have almost sound type system due to some limitations of like computers we're using. It cannot never be like 100% sound, but it's as close practically possible to be sound. Facebook were aware of a camel, and if they were thought about what they're doing and like what are the problems they're approaching like earlier, instead of creating a hack, they could have rewrote part of Facebook or start using like a camel, which already exists, which you don't need to invent in. It's already performant, it's safe, and with your years of building Facebook, you know which part rarely change and where you actually need these guarantees of a sound type system, and which part would benefit from flexibility of PHP when you want to iterate fast, you want to build features faster. So the problem here is not like PHP and a camel and Python, MyPower. The problem is like when you invalidate your decisions, because like it's easy to make a decision like here and now, like here, like I want a sip of water, or like I'll drink water, or like it's done. But like at what point I need to think about, oh, I would need to refill my water at some point, like what would be a good moment? So I have to take create sensors in my organization that like, oh, water level in my cup is low. And then there should be like nice moment, maybe like it's end of day happening when there are fewer users accessing your system, or there like some other kind of maintenance that's already been pre-planned, and it's better like to put them together. So you need to create this flex point or decision point before they arrive. If you want to be cost effective, you should not wait to a problem that like, oh, we're trying to ship using like Python or PHP or whatever, and we like struggling. So you have to say, at some point when our velocity drops below X features per week, we have to look at like, what do we need to change? Where is the problem? It shouldn't be like we stop developing. We should be like, we're not as good as when we started. And this as good should like have a clear number. Maybe you say like, oh, it's fine, we don't have any better solution. But you have to reevaluate these points continuously. Otherwise, you can run into situations where like solution is to develop MyPy or Hug, and most organizations actually don't have a financial capability to do so. So in most cases, if you like, like team of 20, you just like not in a company that have resources like to develop like new virtual machine or like a typer for language that initially didn't have one. And it's like, and you don't want to be in a position when it's a requirement for your business to run like so. Like you don't want to be like stuck with this decision, like how I get out of it. So another example is WhatsApp. So what they did is, so like, what are we going to build? And they knew they're going to build something that's going to send messages all across the world. There will be a lot of small messages. There won't be much of complex business logic, but it's going to be massive, just in sheer size, if not in complexity. So they looked around and say, if you're not very complex business logic and you need massive distribution, there's an Erlang with its Beam virtual machine that already solved it. So why trying to reinvent it later if we can like ready-made solution and use it? And to this day, they're using Beam. They moved from Erlang to Elixir, but it's a cheap move. And again, they didn't invested in developing Elixir. So they just like been careful about like choosing their solution, so they don't have developed their own solution and like pay money for something that doesn't help them. Because for WhatsApp, like developing, I don't know, like Elixir or something else doesn't bring them any money. Doesn't make $0, but it's a massive undertaking. So like decision made at the right time, it actually means saved cost later. And there's a famous multipliers, but costing fixing an error during speccing, it's very cheap. During development, it's getting more expensive. If you found out that during deployment, it will be 10 times more expensive. If your users found it, the damage to your organization would be massive. So like the later you found in your like journey that like you did something wrong, the costlier it will be, and the like multiplying factors are like really nothing to sniff about. Okay. Back to the original point, like architecture and the engineers. So like when architectural decisions presented to engineers, it's usually in the form of like it's a diagram. So like a couple of blocks, they're like your network diagrams, they're like logical diagrams, storage diagram, or like whatever. But it doesn't give you any reason to think that it's a good decision. So when you look at the diagrams, like there are many ways to solve the problem. And when you've seen the problem statement, you already have some idea how you will architect it in your brain. So now someone fighting your decision, but for no apparent reason. So like I have a solution. It's a cost effective because every engineer is an architect. You cannot like just like throw a code around. You have to think about like how it will be structured. So like everyone here like doing the job of an architect. Why is there someone coming in and telling you, no, you have to do it differently? So architect who is like in a position as like full-time architect who is not doing engineering work usually have a different scope of problem. How to protect organization, how to keep organization cost effective. So earlier example with MySQL and Postgres. So if each team have its own RDBMS, let's keep it like RDBMS, like not touching like object storage, then it's hard to tell what is your exposure to security vulnerabilities, because each piece of software have some kind of security vulnerabilities. If you use the same RDMS across your organization, you have this like knowledge that like, okay, Postgres version 13.1 have this known vulnerabilities. We need to account for them. We can mitigate them through our network architecture, through other ways. But like, if you have Postgres one version, another version, MySQL, Oracle, MS SQL, then it's hard to tell how to secure it like uniformly. And when you have like security vulnerabilities, they will be coming like from from many different angles for each piece of software you have. That's why, if possible, the tendency from architects to have a convergence on what's being used. So if you're already using Python, introducing, I know, like Ruby, it's an extra vector for complexity, for cost, for securities that makes it like harder to account for. So there should be enough financial pressure to diverge to take this call. And but then also a good architect have to take into account that like you cannot be stuck. So like if you like code like Python is a good thing, maybe Ruby is better for experimentation now. So architect should make this call like I need more data to actually consider like, do we need to switch? Do we not? So all this coming like under the sea level. So when you see like diagrams behind it, it should be a solution design document, but it's can be easily, I know, like 60, 100 pages long. And when you present it on a meeting, like it's not reasonable. Like when you like, okay, we're starting in a company new project, what is the limitation? So like job of an architect is creating like extract of this document that's specific for this project and for this group of people, because like you cannot present the same view on architecture to engineers, to network engineers, to business people. Like they speak in like different languages. The problem is like it's rarely going deeper. So when architect did their job well on preparing solution design document, but didn't do their job well by presenting information extracted from it, this creates this clash where engineers say like, oh, we have some weird constraints out of nothing. I have like great experience with MySQL and driver entity framework, for example, and like why can't I use it like on the next project? Like, there is a reason for this. So if there are no reasons, then like you have a bad architect. But this is like completely out of like scope of this presentation. So like if your architect is actually doing their work and they like constraining you, there is a good reason, and most likely it's a financial reason, because like architect being asked like what it's gonna cost. So like when I'm working on solution design on individual solution, they always question how it's gonna affect the bottom line, and bottom line is usually money, change in security surface, and sometimes brand reputation. So for example, like organizations always accepting some level of risk, but like what is acceptable? So when business people are saying like, oh, this is fine, like we can accept this level of risk, like actually architect, if organization is big enough, it will be security architect as like a separate person. But when you're accepting this, saying you're accepting this tech risk, it can result to following consequences, and it will be a reputation risk. Can we accept this risk? Because sometimes like it's reputation, sometimes it's a loss of license. For example, like you exposed PII data unintentionally. You created a cool tool, everyone of us is social, and you can see like how your investments compared to your neighbors with like names. So you know, like Jim from a neighboring house invested like differently. It's create a pressure like to work with this bank. You have like more information, you're more engaged because we're again social creatures, but like this actually breaking the law. And if a bank ever do this, they're gonna lose a license to operate. But someone have to pull all of this together. It's usually architect, but then have to distribute it information in a way that it's well understood by all parties. That's why each individual parties usually don't have a good understanding like why is this constraint is exposed, because like they see only like slice of it. Yeah, what you see is like it's not the reason. So like good thing to do, and I was very happy when people like ask me is like, why it works this way. So like you presented a diagram, it's very like straightforward, very simple, but like why isn't like this block have to be here? Why do you need to have the zero trust network? You can have an open network and connect everywhere. Like why do we need to invest it like in zero trust network? And for example, like in large organization, you may need to upgrade all your routers for this, because zero trust network, it's a lot of memory from your routing tables. Yeah, so there should be a justification. It shouldn't be just like a diagram, like we do this, so like there should be numbers behind it. But you cannot put everything. So like ask questions of your architect of security. So like whenever you're presented with a constraint, ask a question. It will make your life easier, and it will make life of an architect easier, because you know, oh, this is a piece that I should have presented. It gives them more information to communicate with you better. So like don't treat diagrams as architecture. Like don't treat final artifacts as architecture. Whenever you have any concerns, go and ask your architects why is it so. And okay, it's end of presentation, but I wanted to touch like another point that like brought up by Kevin last time I presented it, is architects who looking over like multiple teams, so like enterprise architects, they are not the main expert. They like cannot be just by like looking at time. You're working on a like payment system in a bank. You will know in and outs it's like very well. You will know some regulations of it's better. Architects who overseeing like multiple domains can never go deep into individuals one, just by the lack of time. So you're an expert, and you will bring valuable knowledge, valuable concerns to your architects. So bring them up. So it's architect's job to integrate them into like framework, into solution design. But you as a domain expert really like have to, even so it's not probably in your job description, bring it up to an architect. This is a data points that you are missing. You have to take it into account. And the architect should be able to prove that, yeah, I did take it into account, or say, okay, sorry, I'll bring, there will be another meeting, there will be another diagram, I will take into account, thank you. So like, it's a collaboration. It's just a collaboration in many cases with like not that effective of communication. So architects do not dictate. They play in also like a communication hub role in organization usually. So work with them, and both of you will be like happier after. You will understand like where this constraints coming from. It will be like less frustrating, and architects will will give you like better architecture. Like it will be more convenient, and it will be better for organization. Better performing organization means better end of year bonuses. What's okay? Any questions? Yes, sure.
So you have assumptions on your on the part of the iceberg.
Yep.
Right? So is it the architect's job to like lay out the assumptions and say this is what we're assuming, or is it sort of like, well, we're Microsoft, we use .NET?
Yeah. Like, so I mentioned like solution design document. It's probably main document like architect operates on. And one of the things is like flesh out like all the assumptions we made, because we don't have like full knowledge of the whole. So there will be assumption, and it's fine to have them, but they need to be fleshed out. So like we assuming that PostgreSQL will be more performant than MySQL. It's an assumption. We never done a test, but we going with the assumption without like going forward with it, because we at this point don't have a clear picture of what kind of load our system will have, and therefore running benchmark is kind of pointless. But fleshing out that this is an assumption means at some point it's a decision point. Okay, we running this like for a year. Now we can evaluate what kind of load our database is facing. Now we can compare like, is it worth like migrating, or we'll stay with whatever we are here. Assumption, it would be easier to hire, I know, like Python engineers. So yeah, we like started with Python, but we see all Python engineers now like working in AI, and like for our project, like we scraping bottom of the barrel, and Python is not critical for like, let's explore like neighboring fields. Maybe we can find like other kind of engineers, because for us Python is not a cornerstone. We like don't need TensorFlow or other libraries like native to Python. Yeah. Did it answer the question? Cool.
The assumption is to manage the unknowns. Well,
Yeah.
there is a lot.
So
There is a lot of knowns sometimes.
yeah, like you have to acknowledge what you don't know. So like your solution design document have to acknowledge, so like we made this decision, this is a factor, but we don't know how to evaluate it today. So you'll be able to do so. Like, but if you're aware of it, like at some point, like new information, like, oh, right, now we know, and now we need to pivot or don't. And if interesting, like for pivot, it's also a point of like cost versus like savings. So like for some companies, maybe like, yeah, we're struggling like with PHP, we could have used like something with type system, but like what would be the cost of pivot? So what would be the saving and what would be the cost? Again, like it's a job of architects. Look at it like, yeah, we are struggling, but like moving into like a different tech stack, we will struggle like even more, and financially we will like never justify it. Like we have like a new library, like it's better you like using Java, and you decided to introduce like cats with all its fancy the type system features, like but how long will it take to educate our engineers? How long will it take to adopt it? And what would be the actual benefit? Yeah, it looks cool. It will save us like in some corner cases, but will it financially justify this pivot? So like architects also have to say, yeah, we have to stay with a crappy solution because costs are not there. Yeah. Yeah, sure. So there's not much story, and it's a like beauty of it. So there's nothing massive like in the news about WhatsApp, because like at the start, they like actually just made an informed decision, like what are we gonna build and what is the best tool to build it. They like sat, prepared solution design document, and they figure out, yeah, at this point, like probably only company that using Beam in production was Ericsson. And yet, for our case, like the benefit that it's bringing in is so massive that like, yeah, there are not many people on the market that like know it. So like, but this is create this beauty of it, that there's no story about WhatsApp. They just running because like early on they say like, what is the like most pragmatic decision if we ignore like today hype? So at this time probably like everyone like writing Java mostly, but Java doesn't give you like anything out of the box. So like if they would have took Java, they have to re-implement Beam before they can build WhatsApp. Just like open your eyes, look around, and that's what WhatsApp did, instead of like saying like, I don't know. Yep. I hope it answered your question. Okay, if there are no more questions, thank you. If you're interested, like this is a link to an article, which is like more densely packed version of this talk. So you can read for yourself, because like it would be too much to cover everything in just a talk.